Hello friends, welcome to the world of chemistry. This is Dr. Vikram Panchal and I am dealing with spectroscopy, particularly UV visible spectra. This is lecture number 39. In lecture number 38, I was explaining you this example number 6 in which you will find double bonds in one ring and double bonds are also in this ring. So you can take any one of these as a basic system. So we have considered this as basic system, and then this double bond is extension to this one. But here there is no cross conjugation. Why? Because if you go from here to left side, well, there is one system. Here to right side is also one of the system. But these two left and right double bonds which are in the ring of this pentagon are also one of the system. So I think this is not an example of cross conjugation. And as both double bonds are in ring, we call it homoannular diene system, and for that we have taken 253. Then the green will be extra extension of the system. So there are 3 extra double bonds. So we have taken 30 for each one. So total 90 for this one. Exocyclic double bond is only 1. So 5 nanometer, and substitutions are only 2 ring residues. So we have taken 10. So you have to calculate for this lambda maxima. Now second example similar to this one is this one. Okay, but here we'll have to consider the system. So which one is a system? Let us take this one. 1, 2. So here both double bonds are again in one ring only. So we can call it as homoannular diene system. And for homoannular diene system, we have taken 253 nanometer. Okay. Now, in case of this extension of this double bond, well, this one is an extension, but we will not consider this as cross conjugation. Why? Because these two are part of the system only. Now, shall we extend this one up to this? No. Why? Because there are more than one single bonds between two double bonds. So this extension is only up to this one. So there is only one extra conjugated double bond. Remember this. These two are not the part of the system. So extra conjugated double bond. Why? Because there are more than one single bonds between two double bonds. That is why. So only one extra conjugated double bond, and for that we will take 30 nanometer. Now we'll see exocyclic double bond. Well, these two are part of a system, but both are in ring only. So these are endocyclic, but this here, we will see this carbon and this carbon, one is out in the ring, one is outside the ring. So one exocyclic double bond, and for that we will add 5 nanometer. Now ring residue for this one, substitution. Particularly ring residues for this, or alkyl substitution. So from here we start. This carbon is a ring residue for this, but it is a part of system, so we'll not consider this one. Next we'll go here, 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 and then here. So only one ring residue with reference to this carbon. Okay, so there is only one ring residue. For 5 nanometer we will add this one, and therefore now we will have to take the total lambda maxima for this one. Okay, but remember there is one more system in this case, and it is this one, only this one. This is called homoannular diene system. So there is another system over here, and for that we will take homoannular diene system. Because both double bonds are in the system. 253 nanometer. Then extra conjugated double bonds are present or not, that we'll see. Extension is not possible over here, so there will be no extra conjugated double bond. Zero. Next is exocyclic double bond. Well, both bonds are in the ring only. There is no other extension, so there is no exocyclic double bond. So 0 for this one. And ring residue. Let us take this carbon. Yes, this is ring residue for this carbon. Next is this ring. This will be ring residue for this double bond. So there are 2 ring residues. Each one is 5. So total 10 nanometer is added to this. Now you have to add this 2 and find out lambda maxima. Remember, these two are totally different systems. So this is for A system and this is B system. So this is for B system. But they are not in cross conjugation. So there is no cross conjugation even in this case. No cross conjugation. But there are two different systems. So we'll have to consider both. Okay. Next one will be, sorry, number I'll have to see. 8 number. Example number 8, we'll see that this is the example. Okay, let us see what is the system. So we start from here, double bond, single bond and double bond. So this is your system in which one double bond is in the ring, another double bond is outside the ring. So we will consider this as acyclic diene system or non-cyclic diene system or open chain diene system. And for that we will add 217 nanometer. Okay, now here extension is there or not, that we'll have to see, but there are only 2 double bonds, so there is no extension. So extra conjugated double bonds, 0. So we will add 0 nanometer for this one. Next, exocyclic double bond. This double bond is in the ring endocyclic double bond because both carbons are part of the ring. But here, this carbon is in this ring A, but the another carbon is not in this ring A, and therefore this will be exocyclic double bond for ring A. Again, for ring B, this right side carbon is in the ring B, but A left side carbon is not in the ring. So this will be again exocyclic double bond for ring B. So the same double bond is exocyclic for both the rings. So we will take 2 exocyclic double bonds and therefore we'll have to add 10 nanometer for this one. Now substitution, particularly ring residues, because there is no other thing. So ring residues, we'll see from here 1, then this will be extended over here 2, then here 3, we'll go here 4, next to this one is this one, even this one. Okay, so 1, 2, 3, 4, 5 and 6. So there are 6 ring residues and therefore we will add 30 nanometer for this one. So total we'll have to make it to find out lambda maxima. Okay, if anything is left, please let me know. If I have made any mistakes, please correct me. Okay, so in this lecture I have explained you that, but this is not a cross conjugation double bond. Remember that. Okay, so that's it in this lecture. Thank you so much.